What's our question?
You had started out with the if-else statement and stuff from last week, and I don't have that in my notes anywhere from last week, so I don't know if I fell asleep for 5 minutes or what.
Who could sleep through my class?
I don't have it anywhere in my notes, and I stayed up all night last Wednesday night going, but he never said if and then else, you know.
I think I did. Actually, that was from earlier yesterday's class, not the end.
Yeah, I don't have it anywhere in here, which is really weird.
Look at this.
No, that's what we just did.
We just did that?
Yeah.
So I'm still potential. Oh, here. This is from last time.
Yeah, I know. You had it up there earlier.
Aha!
Well, it has to be there somewhere. So, like I said, I must have fallen asleep for 5 minutes.
It's okay. I fall asleep all the time up here. I'm still stuck on the fact that at a Christian university, you had to take 2 weeks of vacation time over Christmas. That is just stupid. And that's recorded, I'm glad. So if the dean or something reviews my lectures. That's ridiculous. I mean, was there any official time you had off?
Well, Christmas Eve, Christmas Day, New Year's Eve, New Year's Day.
So those 4 days were your official. Man, see.
And if they're like at the end of the week, if they're like Thursday and Friday, you have to take the Monday, Tuesday, Wednesday as vacation.
Yeah. Well, see, now you remember this though. Next time some faculty member comes in and starts complaining about stuff to you, we have nothing to complain about. Nothing to complain about. Well, it's like the PhD is like your green card. You know, I spent a long time in college, did a lot of crap, got a PhD, so now I get this nice schedule, but I have no right to complain. What do you have to complain about? Even when I am working, I'm on campus 2.5 hours a day, most days. Wednesdays are my bad days. How many hours do I work Wednesdays? Wednesdays I work 6 hours.
Ooh.
Because you're usually 8 hours every day, right? Oh, 6 hours of my bad day. I'm accustomed to 1 or 2 hours per day.
But you work off campus in your businesses.
Well, yeah, but I mean, I choose to do that. That's like, that's. But even that, I mean, I have like minions.
Do you? Oh my gosh.
I couldn't even imagine. I got Games of Thrones to watch, and I have
not seen television since starting this
I have
5 weeks ago.
Golf Simulator to play in. I had a scare in my league this week in Golf Simulator. I had my match earlier today at the club, and
With Daddy or no?
well, not today. Not today. Her dad is my business partner actually, but we're at the same country club. We're both big golfers, but I'm much better than he is at golf. He's a lot better at me at other things, but I got him in golf. But the guy I was playing against today, he just came out on fire. He was making everything, making putts all over the place. And we have these really nice golf simulators at River Club that, they're like the same things they have on PGA Tour if they ever watch like Golf Channel. And they're like really cool things. This guy was making everything. But the wheels eventually fell off. So I beat him actually really badly. But it didn't look that way around hole 6. In the end, I actually shot a pretty good score. I shot a 76. I don't know if you follow golf at all. I'm pretty decent, but it didn't look like I was going to shoot a 76 relatively early on. But so that was stressful. That was my day. I had a stressful day with that. Then I had to come back and teach for 4 hours. I'm not accustomed to that level of labor. So, you tell if the faculty members come in and complain, and they give you a hard time, you send them to me because they have nothing to complain about. All right. So I said we were going to do a recursive version of factorial. So recursion, another fancy-ish name for something easy. This is when a method calls itself.
A method what?
Calls itself.
Oh, itself.
Sometimes I would refer to this as almost like inline looping. So it's like building in a loop by having a method refer to itself. And we'll see this here in a second. Because the first thing I would bring attention to, here's my factorial slide, right? 5 factorial is 5 times 4 times 3 times 2 times 1, correct? Couldn't we also say that 5 factorial is 5 times 4 factorial? And isn't 4 factorial 4 times 3 factorial? Isn't 3 factorial 3 times 2 factorial? Isn't 2 factorial 2 times 1 factorial? Isn't 1 factorial 1? That's our stop case. So if I were to write, we'll call this guy factorial 2, because he is going to still take in only one parameter, so I can't implement him differently, but have a different type of number and or type of parameters. But so I'll just call this guy factorial 2, and we'll say if n is equal to 1. I'm going to write this in the shortest way so it looks the most compact, so I'll leave the curly braces off for now, but then I'll expand it out with the curly braces. Return 1. So there is the recursive version of factorial. So now we see it's nice and compact. I'll put the curly braces in. So if n is equal to 1, return 1. Else, I don't even need the else. I can just put it afterwards here, because if I didn't do that, I'm going to do this. I'm going to return n times factorial of 2 of n minus 1. Now, technically, this guy is a static method, so I call him using the name of the class in which he was defined, so I would say driver dot factorial 2. So that's the recursive version of factorial. Takes advantage of the fact that factorial of 5 is actually 5 times the factorial of 4. Go ahead.
So then our recursive loop is, I don't know, I've heard the term, what's that then? Like,
Recursive loop?
yeah, isn't that like when it gets stuck in one and then it just keeps going?
That's an infinite loop.
Never mind then.
Yeah, infinite loop would be a loop that never ends. So, for instance, this would be an infinite loop.
I see. How do you get out of that?
Well, you don't. Yeah, I mean, it's a bug in your program.
Oh.
Okay, so here's recursive version of factorial. So let's go ahead and run these real quick. So I'll say driver dot factorial of 5. That should give us 120. Driver dot factorial of factorial 2 of 5 should also give us 120. So we'll see that these guys give us, oh, sorry, I'm not actually printing it out. So I'll print out the factorial of 5, and I'll print out the factorial 2 of 5. Oh, that first one didn't work out so well. I just added a bug into my factorial. Start off at n, keep going as long as I is greater than 1, decrement I each time, answer is equal to answer times n. Oh, that's the problem. It's answer times I for factorial. I started off at n, but they kept getting smaller each time. So inside your loop here, it's answer equals answer times I. for the original factorial. So there's our 120 and 120. This? So I'm calling my two different methods. Calling factorial passing at 5, calling factorial 2 passing at 5, and printing out whatever result. All right, questions about that? All right, so just an interesting thing, recursion. So some things to throw in there about recursion. Any problem that you can solve recursively, you can solve iteratively using loops and something called a stack. A stack is a data structure that we'll talk about in the second portion of this course, the 537 class, the second 8 weeks if you keep on and take it. The second 8 weeks, otherwise I think it's offered in the fall, maybe the first 8 weeks of the fall. I don't know when it's offered, but I'm teaching it any way you cut it. But we talk about the stack data structure in there. So anything you can do recursively, you can do iteratively with a stack. So internally, our computers have something called a stack. And a stack is like a stack of magazines. So you keep piling things on top of other things. So the way recursion works is, let's say I was calling this on 5. So I'm going to call it the very first time, passing 5 in for n. Is 5 equal to 1? No. So I'm going to return 5 times whatever the factorial of 4 is. Until I get this answer, I can't return this line. So this gets put on hold. It gets pushed onto the stack until, and then we make this call. So now we're calling for 4. Well, is 4 equal to 1? No. So we're going to return 4 times the factorial of 3. Well, until I can get the factorial of 3, I can't answer this line either. So I need to put it on hold. I push it onto the stack. Now we're at 2. Is 2 equal to 1? No. So I'm going to return 2 times factorial of 1. Until I get this answer, I can't go any farther. So I push it onto the stack. Then I call this on factorial 1. Is 1 equal to 1? Yes. We have an answer. So now we can calculate the factorial of 2, which is 1 times 2, which allows us to calculate the factorial of 3. Pop it off the stack, calculate the 3. Pop it off the stack, calculate the 4. Pop it off the stack, calculate the 5. So we had to put those all on hold while we had to wait for each future thing to get calculated. For the factorial of 4 to get calculated, we had to wait on 3. For 3, we had to wait on 2. For 2, we had to wait on 1, and it just so happened that 1 was our stopping point. Finally, we stop making recursive calls when we get to a 1, and we just return 1, the hard-coded value. And that's when the recursion unrolled. That kind of makes sense? So, recursion is not something you will use terribly often. There are some problems that really lend themselves to recursion. So the solution, recursive solutions tend to be very short. So we saw that it was pretty compact compared to the iterative version of the solution, right? So recursive solutions tend to be more compact than their iterative equivalents. They tend to be significantly more memory inefficient. We just kind of walked through that. We were putting multiple copies of this method on hold while we waited for future things to get calculated. That's a big memory hog. We had to remember the state. Just for calculating factorial of 5, we had to remember the state of 5 versions of this method until we can finally unroll the recursion. Make sense? So it's not memory efficient at all. But sometimes that's okay. Sometimes elegance is more important than memory efficiency as long as the problem we're solving isn't going to cause us to run out of memory. Okay, so a lot of times recursive solutions tend to be very elegant solutions. But it's, again, the right tool for the job. I would say 97.25% of the time you're going to be using iterative loop-based solutions. Every now and then you'll run into something that just kind of makes sense to solve recursively. I mean, this was a good example. Factorial is recursive in its definition. So it made sense to solve it recursively, even though we could easily solve it iteratively. No big deal. Okay, questions about recursion, any of that crap? All right, so let's keep trucking and let's talk about an object type. String. We've actually already used them a little bit. We just didn't really know we were using them. We didn't really use them to anywhere near their full potential. Strings are object types. Object type variables. Specifically, they are a named collection of char primitive types. Strings are surrounded by double quotes. Okay, so the thing that designates something as a string is that it starts with a double quote and it ends with a double quote, and it's filled up with 0 or more chars. That is to say, that guy is the empty string, the string with no characters in it. Make sense? Okay, so some examples of strings. Hello world is a string. So let's go and create some strings. All right. Does everybody have all this code written down that they want? Scream now. I love doing that in our more advanced classes where we just spent like 4 class periods creating something really complex. I just delete like a whole bunch of like gold code for like, and the students are just, they're very depressed by that. All right, so I'm gonna create a string. String S is equal to hello world. String S2 is equal to elephant. System.out.println S. System.out.println S2. This will print out hello world, and it'll print out elephant. What will the output of this program be? Hello world. I'm not trying to trick you. What'll print out here? 5. What'll print out here? Hey, what'll print out here? True. What'll print out here? 3.14159, right? So I have a method called println. Println must exist more than once. Polymorphism is at work here, is it not? Because right here I'm passing it a string. I'm passing it a string. I'm passing it an int. I'm passing it a char. I'm passing it a boolean. I'm passing it a double. Same exact method name, but I'm passing it a different number and or type of parameter. Right? Okay. So let me quickly go and show you that. So I'm going to go to the Java documentation. So we're going to start using that quite a bit. So I'm going to go to java.sun.com. It's the website. And that's going to redirect you to Oracle. Then down here on the right, I'm going to click on Java SE. Then over here on the right, under Java Resources, I'm going to click on Java APIs. Abstract Programming Interface is what API stands for. Then in the center, Java API Specifications. Under Java Standard Edition, that's what the SE stands for. You can really pick any of the top two. Just pick the newest one, Java SE7. And this is going to bring up the Java documentation. Okay, now I'm going to go into something up here called java.lang. This is something that's built into the language. We'll talk about this quite a bit, but for right now, just bear with me. So inside of java.lang, we find a bunch of classes, and one of those classes is called system. Inside system, we have something in here called out. And this guy is something of type print stream. Doesn't matter what it is, doesn't matter what a print stream is, but I'm going to click on it so we can go look at all those println methods. And we're going to see, starting right here, we have a whole bunch of println methods. The same method that takes a different number and or type of parameter. Here's a version that takes a boolean. Here's a version that takes a char. Here's a version that takes a char array. Here's a version that takes a double, a float, an int, a long, an object, a string. Okay? So there's polymorphism at work. We have multiple versions of the println method that takes in different types of parameters and knows how to display those types of values. Make sense? Okay, we're going to end up talking about that in a lot more detail because there's some interesting stuff that's going on in there. But for right now, I'm going to leave it at that. But I just kind of wanted you to see where in the world this stuff kind of happens. Okay, this println thing isn't some magical container that I can throw anything into and it just spits it out. Okay, they had to write it multiple times to cover the various variable types that are built into Java. And most importantly, this guy right here is our catch-all, println object. That's for everything that wasn't built into the language that we write. So we can create our own objects. Well, I guarantee you the guy at Sun Microsystems who wrote Java 20 years ago didn't know that we were going to write a class named dog next week. So he didn't know to write a method that knew how to print out dogs. So he had to have some sort of generic equivalent to be able to print dogs and then give us the necessary tools to make that make sense. And we'll talk about that when we start writing our own objects. Okay? So I promise you it's there. But that's the infrastructure that's happening under the hood here. Okay, I'm going to leave the documentation up for a few minutes because we're going to come back to it as we look into strings more.
Where was that after you clicked java.lang? What did you click after that?
I clicked on system down here on the left.
Oh.
system.out.println. So I went to system. So if I click on java.lang, down here on the left, there's a class under classes called system, capital S.
Gotcha.
And then after I clicked on system, up here at the top, we have something called the field summary. We'll talk about fields, but for right now, just click on the print stream to the left of out. That's the kind of animal that out is. So system.out is a print stream. And print streams have these println methods. All right. So we have a couple of strings. Let's do some things with strings. So we have something called string concatenation. Another fancy word that means glue strings together. Or glue stuff together into strings. The output of concatenation will always be a string, but all the components of a concatenation don't necessarily have to be strings. And we'll see this in a second. Okay, so for example, I can take the string hello and I can concatenate that. So the concatenation operator is the plus sign. But wait, isn't the plus sign the mathematics addition operator? Yes, it is. Java knows which one you're talking about depending on, are you calling it with strings or are you calling it with numbers? So hello concatenated with world will result in a single string, hello world. Like that. All run together because there's no spaces in there. Go ahead.
What happens if you do like quotation marks, hello, plus, and then just the number 4?
Okay, we're getting there. Coming real soon.
Sorry.
In fact, how about the very next line?
Oh, I was just,
Hello, you want to do this. Like that, right?
yeah.
Output will be this. Hello 4. Just like that. But why?
Because one of them's a string.
One of them's a string. And that's the correct way to say it. One of them is a string. Because what if I say this? We might think, hey, maybe this is an error. Because the first guy is an int, maybe it's going to treat the plus sign as the addition operator and try to do some sort of crazy Martian math by adding 4 to the string hello. What's that going to come out to? But nope, in this case, the output will be 4 hello.
Because it's a multi-pass thing. Right?
Well, because of what? Well, I don't think it's because of the multipass compiler in this case. It's how string concatenation works. And what you said is very accurate. It's because one of them is a string. Not because the first one's a string, but because one of them is. So if a string is found as one of the sides of the operator for the plus sign, that guy's treated as the concatenation operator. Otherwise, it's treated as the addition operator. So you better have something mathable. I just made up that word, but it's a real one. I didn't just make it up. I think I've been saying it for at least several years, but I'm pretty sure I made up mathable. Have you ever heard that before? But you know exactly what it means, right? Genius. Have me update the dictionary. All right. So that's string concatenation is gluing strings together. Or gluing stuff together, making strings. So this is how we build strings. So coming out here, I can take S, concatenate it with S2, and that will give me hello world elephant, all strung together. Similarly, I can say S, concatenated with the string containing a space, concatenated with S2. And that will give me hello space world space elephant. Make sense? Okay, now.
Wait a minute.
See, I asked you if any questions a second ago, and you missed your opportunity. Yeah, go ahead.
You said something before the string. What was that?
Huh?
You said something before that S plus the quotes plus S2. What did you say before that?
Before that, I had it looked like this.
Oh, okay.
S concatenated with S2, so it would come out to hello, space, world, followed by elephant with no space. Because I just run it all together.
Oh,
Okay, because this literally glues this string to this string.
and if you put the quotes in there.
Yeah, so I just built in a space.
Okay.
So I concatenated onto S, an extra space. And then concatenate on, because understand that this guy right here, that boils down to a new string. And the string it boils down to is a string hello space world space. Then I'm taking that string, I'm concatenating onto that S2, which is elephant. Make sense? So it still works through this systematically. Alright. Now, so a little modification of what we had earlier. I'm going to create a method here called BuildString. This guy is going to return a string as its output. And as an input, he's going to take in a character as well as a number of times. And for example, if the character we passed in was a C and the number of times was 6, I want this guy to return the string CCC, CCC. 6 C's in a string. Make sense? So similar to what we did before when we printed out char C times number of times. But now we're building a string using the concatenation operator. How would we write this? Well, I can do my loop that's going to go through times number of times. That hasn't changed in terms of our patterns. I equals 0, I is less than times, I plus plus. So that loop will take I on a voyage where each time through I is, well, the first time through I is 0, then 1, then 2, all the way up to times minus 1. So this will go through times number of times. But before, we did something like this, system.out.print C. And at the end, we did system.out.println. And that printed times number of C's to the screen, times number of whatever the character inside of C was. But that's not what we want to do in this case. In this case, we want to create a new string that contains the number, that contains times number of whatever char is in C. How would I do that? I need to build a string. We build strings using concatenation. So the best trick we have is the empty string. The empty string is literally a string with nothing in it, but it is a string. So since it is a string, we can use the concatenation operator with it. As an example, string S right here. Int 5, int Z is equal to 5. String S is equal to the empty string. S is equal to S concatenated with Z. That will result in the string containing a 5. So if we take the empty string and concatenate onto it an int, we get the string version of that int. Does that make sense? Now that might not seem that powerful, but it's actually one of the most powerful things we have in Java. I say that Java is a language that's known as a string-based language. Strings are very, very important in Java. So important that Java has actually treated this object type variable. Strings are objects. We're going to see that here in a minute. But they've treated them a lot like primitive types. So much like primitive types that in many ways, strings are more like primitive types than they are like objects, except they can do a lot more than primitive types. And I'll prove that to you probably next class, if not the class after that. I don't have all the tools. You don't have all the tools that for me to explain that to you. But in any case, so what I do is I start off with a base string that's the empty string. Each time through this loop, what do? I take my string answer, and I say answer is equal to answer concatenated with C. And then in the end, I return answer. This is a class method. How do you know? Word static is before its definition. How do you call class methods? We define class methods, putting the word static in front of their definition. How do we call class methods? Using the name of the class in which the method was defined. Huh? In this case, it would be driver dot. Yep. Using the name of the class in which it was defined. In this case, the name of the class is driver. So we would say driver dot BuildString. But if we had defined it in a different class, not named driver, you wouldn't say driver dot. You only say driver because it's in that class. So we're going to say driver dot BuildString, and we'll pass it Q, and we'll pass it 14. And this just spits out a new string. So string S will be equal to that. Then we can say system.out.println S. So build string, we're going to pass it in the two parameters. This guy's expecting a char C and an int times. So I pass it the char Q, and I pass it the integer 14. This guy's going to do its magic and spit out a brand new string that is Q 14 times. I'll store that string inside of this variable named S, and then I'm going to print out whatever's in S. Make sense? I gotta check something here real quick. I want to make sure I don't accidentally give you any solution to your homework assignment. Oh my gosh, number 4 there is a nightmare. Don't even read it. It'll just bring you to tears now. All right, so do we understand this? How this one works? Okay. So, next we're going to want to write a method called reverse string. Reverse string is going to take a string as a parameter, and we're going to return whatever that string is in reverse. We have one problem. We know how to do part of this problem already. Whether you think you do or not, you do. But how many characters are in S? This guy right here. We don't know. S is a parameter. It's a generic parameter of a generic method. So the number of characters in S is variable depending on what string we pass to reverse string. Correct? Remember when we talked about objects, we said that objects as compared to primitives. Primitives are built-in variables built in the language that can only hold a value. Objects can hold 0 or more values. They don't actually have to hold a value. Most of them do, but they don't have to. They can hold 0 or more values, and they can potentially do more. That potentially do more thing, one of those potentials is methods. Objects have methods associated with them. So we're going to learn about a couple of these methods today. First method we're going to learn about is a method that returns an int. It's called length and takes no parameters. This is the definition of the length method. What is noticeably missing here from the methods that we've defined? Well, that's calling it. Here's the methods that we've defined. It's missing static. Class methods have static out front. The other type of methods we have are instance methods. Instance methods do not have the keyword static at the beginning of their definition. So if you're looking at a method definition, the only thing that we can use to differentiate as to whether or not it's a class method or an instance method is whether or not we see the word static there. If we see static when it's being defined, it's a class method. If we don't, it's an instance method. Now, there is there might be some evidence how the method's written, how it's being called, that kind of stuff, that might let us speculate as to why it was implemented as a class method or an instance method. We aren't going to be able to really talk about that until we start writing our own objects. So for right now, we have to just settle for this concept that there are two types of methods just cause. Okay? So we have instance methods and we have class methods. Instance methods do not have static in front of them when they're being defined. Class methods do. Instance methods are called using an instance of the class in which they were defined, rather than the name of the class in which they were defined. Class methods are called using the name of the class in which they were defined. Instance methods are called using an instance of the class in which it was defined. Okay, we'll see what that means here in a second. Well, several seconds, but. I could feel the caffeine coursing through my body. Did you know that Mountain Dew doesn't actually have more caffeine in it than other sodas? You did know that?
Is it like 35 or something, whatever the units are?
Well, I'm not sure about that. You're ahead of me on this one. But I'm pretty sure Mountain Dew is either the same or less than most sodas. When most people think of it like Mountain Dew, high caffeine, right? Now, you want high caffeine, you got to go back to that Jolt Cola. Have you ever had that? Jolt? They still sell it online. I think you can buy grape Jolt. Still, that was when I was a lot younger. That was the programmer's beverage of choice. You stay up for multiple days on. That had caffeine in it. Actually, it'd be interesting to do a Google search sometime just to see Jolt soda versus like these energy drinks today. Because they took Jolt off the market because people were having heart attacks with the amount of caffeine that was in it. So all these new energy drinks today, a lot of them don't even have caffeine. They're all sorts of weird herbal teas and stuff like that, right? I don't know.
You're wrong, Mike.
It's what, it's got more caffeine?
For Mountain Dew, a 12-ounce can it says 54 milligrams.
Okay.
And then Pepsi, which is what I was thinking of, it says for a 12-ounce can it has 38 milligrams.
Maybe it's that Mountain Dew doesn't have the most of all sodas in caffeine. Maybe that's it. There's something that people had to common knowledge that Mountain Dew is the most caffeinated beverage.
It's not, though.
I don't think it is. Yeah, those energy drinks. Any of you big energy drink fans? Those things can be dangerous, I think. I had a student in one of my classes last year. I mean, who knows if this was the cause of it, but, his nickname was Voltage. All right? You would never see him walking around either drinking Voltage because he would have Mountain Dew Voltage, whatever that is. But then he would always have energy drinks and stuff like that. He was sitting right there, middle class, had this huge seizure.
Oh.
Huge.
Scary.
Yeah. I thought he was dead. I've never seen somebody go from looking completely normal to blue that quickly. And who knows if it was from that or not, or if he was just having some other health things. He's in my class. He lived. I see him Monday, Wednesday, Fridays in class. Now we call him seizure. But actually, he called himself that, so we kind of go back and forth. But so we kind of speculated he drinks a lot of those energy drinks, like more than you think a person should drink.
I think it has my nose. They smell so awful.
Oh, I don't drink them. I'm a high energy person. You can't put any more fuel into this. If I could make programming this exciting. All right, instance methods. No keyword at no static keyword at definition, and we call them using an instance of the class rather than the class name itself. All right, back to here. Where is my length method? There we go. Back to here. String methods. Notice that this is the method definition. I haven't shown you the actual implementation of it because I didn't write it. Somebody else wrote it. So I'm just showing you it exists. I'll show you the documentation in a moment. But notice that in its definition, the word static does not appear out front, which means that we can tell by the definition of this guy that this guy is an instance method, which means that we need to call him with an instance of the class in which this method was defined. And this method was defined inside of the string class. So I'm going to go to the documentation. Upper left-hand corner, a good starting point always. These are all the packages built into Java. Everything that's available to us by default is inside of a package called java.lang. So that's a good starting point for us right now. So java.lang, this is the crap we have available to us without doing anything else special in Java. Okay? This is the core Java language, java.lang. Inside here, we'll see we have a bunch of classes. One of these classes is called string. Make that a little bigger. Is that good size? Okay. So first of all, right at the very top, we'll notice that objects, well, here's string. String is an object. It inherits from something called object. In an object-oriented language, all objects, somewhere in their lineage, have the original object in that hierarchy. So strings are only one level removed from the original object. Okay? We'll talk about that a lot more when we start writing our own objects, but more just a factoid I'm throwing out there for right now. Things to kind of throw into your head so you're, even if it's subconsciously thinking about it at some level. Okay. So I'm going to scroll down. I'm going to skip the constructor and field summary because those are things we don't know about yet. I'm going to get down to methods. And inside here, we're going to see that we have a method. It's alphabetical order, but I'm only reasonably decent at that, called length, right there. And we see that the length method returns an int. So over here on the left, that's its return type. The name is length. And what does this guy do? It returns the length of this string. That is the number of characters in this string. Notice that there is no static over here. Okay, no static out front. So, the way we call this guy is using an instance of the class in which this method was defined. This method was defined inside of the string class. So we're going to need instances of the string class in order to call this. Get rid of that for a second. So right here, I've created a variable named s. S is going to hold the result of the BuildString method. Here, I'll create another variable too, just so we have a couple of options. S2 equals elephant. So I'll put the string elephant in that guy. Okay, so I have two variables. One's called s, one's called s2. S holds the value that's returned by calling BuildString with q and 14. Okay, so that's going to hold the return value with 14 q's. S2 holds the value elephant. Okay, now, how do I call instance methods of the string class? Like length, I call them using an instance of the class in which length was defined. So I say s.length, s2.length. What should s.length return? This is where s is built right here. What is s's length? 14. S was built as a result of calling BuildString where I passed in q and said give me 14 of those. So s should have a length of 14. What should s2's length be? Elephant has 8 characters. So that should be 8. S.length is 14. S2.length should be 8. So there's my 14 and my 8. That makes sense? So it's the exact same method that I passed no parameters to, but it gave me different values because length belongs to S. And it knows how many characters are in S. The second call to length here, this guy belongs to S2. And it knows everything there is to know about S2, specifically how many characters are in S2. Okay? So these are instance methods of the string class. How do we call instance methods? An instance, using an instance of the class in which the method was defined. How do we call class methods? Nope. Using the name of the class in which the method was defined. How do we define class methods? Static. How do we define instance methods? No static. Don't worry, I might ask you that 1 or 2 more times per minute. Okay, so are you ready for a trick question? Because you're all claiming you understand this, right? What's S? Tell me everything you know about S. by the way we're using it here? Or just in general? What's S? I thought you were going to say that. I thought you told me you understood this stuff. What's S? Ah, I heard something good back there. It's a variable. S is a variable, right? How do you define variables? Type, variable name, value. So what's S? S is a variable. What are variables? If you had to give a concise definition of what a variable is, what would you say? Named container for holding a value. That's what a variable is. S is one of those. What does S hold? What value does S hold? Remember, you told me you understood this. The funny thing is, I'm actually going to let you get away with a lie for now. Because I haven't told you enough for you to have the real answer. So what does S hold? What value is in S? What do you think? What's the value in S? Everybody's gun shy. What do you think? Take a guess. What's the value in S? Yeah, that's true. It is whatever value that is, and what value will that be? Q 14 times. Okay, so S holds Q 14 times as a string. Okay, now I'm telling you that's actually a slight lie. What S really holds is a memory address, which points to the place in memory where Q is held 14 times. But I haven't shown you enough yet for you to appreciate that yet. So for right now, we're going to stick with the lie that S holds a string. S is a variable that holds a value, and that value is a string containing, in this case, Q 14 times. And actually, what's interesting about that last little statement there is that's also the reason why I do not use a textbook for this class. So I saved you $200 or whatever those textbooks cost. Because all Java textbooks that I've looked at are liars. There exists something, I'll talk about it again, but there exists something called a pointer. It's a primitive type. Pointers hold memory addresses. So the pointer primitive type is a memory address. Well, Java textbooks claim that pointers don't exist. In older languages like C and C++, there was a specific syntax for pointers. It was an asterisk. And when we get into pointer stuff, I'll talk about it a lot more. But the punchline here is that most Java textbooks specifically say that pointers do not exist in Java, which is a flat-out lie. The truth is, Java does not have a specific syntax for pointers, because in Java, everything is a pointer. There's a big difference between saying they don't exist to saying that everything is them, or is one of those. Okay? That's about as much as I can tell you about them right now. I'm going to go into a lot of detail with them, either next class or the class after that, when we get into arrays and objects, where I can really show you these things that don't exist. Okay, we'll print them out to the screen. Yeah, clearly it's a lie. But, yeah, I don't know. I don't like textbooks that lie. I think it shows a fundamental misunderstanding of the language. And also the reason that Java exists. One of the problems with older languages like C and C++, really the reason that Java exists is because of weaknesses in C++. And one of those weaknesses, specifically for beginning programmers, is when you're manipulating memory directly, you can run into problems. Beginning programmers make a lot of mistakes. Nature of the beast. Okay? I didn't pop out of the womb writing error-free code. Okay? I've made my zillions and zillions of mistakes, and now this stuff isn't very difficult for me because I learned all the things not to do. Okay? But the point is that for beginning programmers doing C++, you're manipulating memory directly using pointer arithmetic. And it's dangerous as far as you could say that you might crash your computer from the point of view that you'll have to restart your computer because you overwrote some part of memory that your operating system resides in. So we're not talking about real death to your computer crashing, but inconvenience 3-minute reboot crashing. But moreover, C++ empowers the programmer to make some very bad programming decisions. And just a high-level example, I won't get into it very much here, but in the real world, let's say you were having a party at your house, and you were inviting your best buddy Mike over to your party, right? Clearly, I'd be the life of any party. I get no smiles at all, anything from that. Killing me. Okay, so let's say the party's tonight at 8. Do you give me the address of where your house is? Or do you hand me your house and tell me to open the door at 8? In real life, what do? You write your address down on a piece of paper, right? Why? Houses are heavy. Okay, that's why. Well, C++ lets a programmer pass the house as opposed to the address to the house. In real life, would it ever make sense for you to hand me the house and tell me to open the door at 8? That would never be an acceptable solution in real life, correct? Why should it be in C++? The difference is that C++ empowered the programmer to make decisions, which is cool. Okay? But some of the decisions they empower the programmer to make, the programmer should never make. But that's two-sided. I mean, it's actually very important for computer science today that C and C++ existed because just because it's easier for me to tell you that this is the way it is, just do it this way, as opposed to this older language put the burden on the programmer to do it right. It let them choose to do it wrong. It never makes sense to do it wrong, but technically it's not completely inaccurate to do it wrong. If you could lift your house and I could hold the house for that many hours, I technically could attend your party by opening the door at 8. This is nowhere near efficient, but it's possible, right? Java exists because C++ empowered the programmer to do a lot of things like that added a level of flexibility to a language like C++ that allowed you to do a lot of very powerful, correct things. But because of that flexibility that was afforded to you, you could also do a bunch of really stupid things. Java went in and said, here's all the crap you should not be able to do. They removed it from the language. And in doing that, Java took over the burden of how to handle memory. What things are passed by address as opposed to which things are passed by value. Things like houses, always passed by address. Things like a quarter, maybe we pass that by value. You would hand me a quarter. You wouldn't give me a little slip of paper telling me where to go find the quarter. Right? Make sense? Okay, so, I mean, I'm saying this in a joking way, but the reason Java exists is because of some of those weaknesses in C++. And for a Java textbook to specifically say pointers don't exist in Java is really a...
it's like saying you're only handing people houses?
No, it's like them saying that all the problems Java solved It's not giving credit to Java for the problems they solved. By saying pointers don't exist in Java isn't giving Java the credit it's due. Because in Java, everything is a pointer that should be a pointer. Therefore, there is not a specific syntax for pointers. So Java does all the work for you. If it makes sense to pass it, give you the quarter, Java will give you the quarter. If it makes sense to give you the address where the house is, Java will make it work that way. Java makes that decision. And it's very clear cut. It's not a difficult decision to make. I mean, once a programmer learned their lessons in C++, they started doing it the right way. But to say Java doesn't have pointers is a lie. Java does have pointers, they just don't empower the programmer to choose when to use them and when not to use them. That make sense? It just works in the best way. So that's the rant as to why I don't use a textbook. It's all in here somewhere. Sometimes get a little crisscrossed or something, but it's actually going to be very funny when I finally start losing my mind. Because I rely on so much, the stuff's just stuck in there. I don't write anything down. I'm going to be a really funny, crazy old person. My wife believes that too. Because, wives don't like it when you joke around while they're fighting with you. She says they don't take anything seriously enough. Should you really take life that seriously? Nah, it's not worth it, right? Killing me. What was it talking about? Oh, length. Length. Build strings. Length. S. S is a variable. S holds a value. The value it actually holds is a memory address which points up into memory where Q 14 times actually lives. For right now, we'll operate under the lie that S actually holds the string Q 14 times. Realistically speaking, it's not horrifically inaccurate to say S is a string. So I've belabored this a little bit because your original answer is what's S? S is a string. That's not inaccurate. Ultimately, S does boil down to a string. After you peel away a couple of layers, S is a variable. We open up that package. Inside of that's a pointer. We follow that pointer. We find a string in memory. So at the end of the day, what is S? It boils down to a string. Make sense? All right. So since S is a string, right here we have a variable named S. It will boil down to the string contained within S. And we'll call the length method, because length is an instance method. We call instance methods using an instance of the class in which they were defined. So this guy will print out 14, the number of characters in the string S. This guy will print out 8, the number of characters in the string S2. Make sense? So we think we understand that? I'm about to trick you.
Where would you use that? Why would you need to have the length of the string?
We're about to write reverse string. By we, I mean you. Maybe the short answer to what you're asking is all the time. When do we use it? You will literally use it a very, very, very high percentage of the time from this moment forward. Because Java is a string-based language, and in order to work with strings, we often need to know the length of the string. Even though we can look at the string elephant and say, oh, that has 8 characters in it. When we're working with something programmatically, a lot of times inside of a method when it's generic, when we take a string as a parameter, how many characters are in the string that we took in as a parameter? Well, we can't just come up with a number 7 or 14 or 8. The number of characters in it, if our string parameter is called S, S.length number of characters. That's how many characters are in that string. Go ahead.
So say you have like elephant, or say you have like pie or something, right? And you want to print out only like the first 3 letters, the first 3 digits or something. How do you make it do that?
Oh.
Does that use length?
It's a very interesting question. So you want this guy, you want to say print first,
Three.
well, let's call it first, well, yeah, first 3. I'm good with that.
That's just what I was thinking.
Okay. And you want that guy to take a string as a parameter?
Yeah.
Okay, I think that's an excellent idea. You could help us write that, right? So she wants to write a method that takes a string as a parameter, and she wants it to only print out the first 3 characters in that string. First of all, what should it do if we have a string that doesn't have 3 characters in it? What is S-ling? How many characters are in S? We do know. Exactly, right now, how many characters are in S? Give me the exact answer. Right here. The only part of the world you see. It's right here. How many characters are in S? We absolutely know.
3.
You're just guessing.
Yeah.
I thought you said you understood this stuff.
Of this yet.
Well, you only have S, and S is a pointer.
S is a variable that holds a string.
Yes.
How many characters are in S? Just spent the last 15 minutes talking about this. How many characters are in S? Why 3? Because I wrote the word 3 here? Those things are somehow correlated? Man, I was about to trick you with something easier than this, or harder than this. But I can trick you with this easy stuff?
0.
Okay, why 0?
What's the default?
No. All right, so we have 2 strikes. Faye, did you strike out already?
Yeah.
Oh, okay. So what we got? What do you want to take your guess? I mean, I'm looking for the exact. I want the exact number of characters that are in S. 1? Why 1? What's your rationale? Why do you think 1?
Because you said exact.
Okay.
So, 1 refers to S.
Oh, because S has 1 character in it? Yeah, no, that's not going to cut it. All right.
Because it's 0 and 0 is 1 character,
No.
so it's still 1.
Because hold value.
Everything you need to answer this question you've learned in the last 15 minutes. And it's not even a hard answer. I think you're really overcomplicating this. The number of characters in S is S dot length. What does the length method do? It boils down to the number of characters in the string that called it. It's an instance method. Instance methods are called by an instance of the class in which the method was defined. Up here, we saw S call its length method, where S was 14 Qs. This printed out 14, correct? We saw S2 call its length method. On elephant, this printed out an 8. Why? Because S2.length is 8. S.length was 14. Well, I promise you, inside of here, inside of this generic method, S.length will be the actual number of characters inside S. So while this method is running, S.length will boil down to the number of characters. So before we even do this print 3 thing, let me really drive this point home. static void print length string s. System.out.println s dot length. So I'll call this, first of all, class method or instance method. Class method. How do you know? Because I use static when I'm defining it. How do I call class methods? Use the name of the class in which the method was defined. So I'm going to say driver dot print length. And we create a couple of strings here. String s is equal to hello. String s2 is equal to elephant. So I'll pass s, and then I'll call driver dot print length s2. And what does print length do? It takes some string s and it prints out however many characters are in s. So the first time I call print length, it's taking hello as a parameter, right? How many characters are in hello? 5. So this guy will print out 5 for that particular call. Second time I'm calling it, I'm passing it s2, which holds elephant. How many characters are in elephant? 8. So it'll print out 8 that time. So this should print out 5 and 8. Methods are reusable chunks of code and they're written generically. So this is a method called print length that returns nothing. And he takes a string as a parameter. So whatever string I pass him, we are guaranteed that this guy is always called with a string. Whatever string I pass him will always have a length of s.length. If I pass him the string hello, s.length will be 5. If I pass him the string elephant, s.length will be 8. So on and so forth. That make sense? Okay, so now let's get back to the previous question. You wanted to write a method called print first 3 that takes a string as a parameter. First of all, how do you want this method to behave if the string you pass it has less than 3 characters? Just print out the whole string?
Yeah.
Okay. How do I ask the question, does this string have less than 3 characters?
S, like, is less than 3.
Okay. S.length is less than 3. You're going to say system.out.println s. So that's what we'll do in the special case that the string we pass it doesn't have enough characters to print out just the first 3. Okay? So if I pass this guy something with less than 3 characters, let's not try to access those individual characters. Okay? Else, I want to access the first 3 characters. That is the character at position 0, 1, and 2. Okay? Create a little loop for int. Well, actually, we'll do this the simple way since it's only for 3. So in order to do this, we need to learn about another method. We have to know how do we extract a single char from a string. So we have a method that returns a char. It's called char at, with capital A in the at. And it takes an int index as a parameter, an int I, int n, whatever you want to call it. And it returns the character at position index in the string. And let me show you what that means. So let's say that I have string s is equal to hello, like that. Okay? So that's string s. That guy is going to look like this. Oh, hello. And actually, each of these is a char. Okay? So this is S. S is 5 individual chars, with H being at bucket 0, E being at bucket 1, L being at bucket 2, L being at bucket 3, and O being at bucket 4. So strings are 0 indexed. So S's length is 5. S's legal characters are 0 through 4, or 0 to length minus 1. So if I were to say S dot charat 2, that would boil down to this L, the character at bucket 2 in S. S dot charat 0 would boil down to the H, the character at bucket 0. Make sense? So, in our code here, to print the first 3, if I'm in this else, I know that S has at least 3 characters. So I'll say system.out.println, we'll just print them one per line. S.charat 0, S.charat 1, S.charat 2. Like that. So I'll say driver dot print first 3 S. That should be HEL. Then I'll say print first 3 S2. That should be ELE. And then I'll say string S3 is equal to, how about just A? So for that guy, he should print out an A, the entire string, because he doesn't have at least 3 characters. So we should get HEL, ELE, and then just A. HEL, ELE, and A. Okay, so that's the charat method and how it works. I'm going to show you another method. We have a method that returns an int. It's called index of. And it takes there's 2 of these. It takes a char as a parameter. There's also one called index of that takes a string as a parameter. And each of these guys returns the first index of either C or S in the calling string, the position of the first index, or -1 if it's not found. So each of these returns as an integer the position of the first occurrence of C or S in the calling string, or -1 if it's not found. That -1 if it's not found part is extremely important for many homework assignments, possibly this upcoming one. Hint, hint. So let me show you how index of works. So I'll say system.out.println s.index of the character E. Where is E located inside S? It's at position 1, correct? HELLO. So the E is at position 1. This will print out a 1. Because remember, strings are 0 indexed. So there's our 1. Where is L in HELLO? Index of returns the position of the first occurrence. At position 2, not position 3. It's at position 2. What if I passed it the string LL? That version of index of. The first occurrence of the word LL is at position 2. That's where it starts. Make sense? The first position of LO, though, is at position, sorry, I think that's L0. LO is at position 3. It starts at position 3. So this will boil down to a 3. Yep.
I tried to shortcut when you put system out println and then s dot char at down there at 0, and then tried to just use like the and so that it would print all of them. But
You mean the plus sign?
I used the
Ampersand?
yeah. Is that wrong?
No, that's the and operator. You want the plus sign to concatenate. You need to make sure you have a string somewhere in there. These guys are all chars.
This doesn't like it.
Write it like this. Empty string concatenated with that, concatenated with that, concatenated with that. No, I don't like it.
It's not perfect, but
Well, that'll print out as a string. That'll print out bucket 0, bucket 1, bucket 2 as a string. If your code looks like mine, that's exactly what it does. I can look at it at the end if you want. All right, so s.index of LO is going to print out 3 because that's where LO starts. Make sense? Similarly, s.index of Z. Where is Z inside there? It's not found, right? This will boil down to a -1. I want you to ingrain in your soul somewhere that index of returns -1 when I cannot find something I'm looking for. That is a problem-solving tool that you will find very happy. Very, very happy, very helpful. So it will make you very happy. Okay, let me quickly look at the assignment. I want to make sure I've given you all the tools you need.
we're gonna reverse the string.
We'll do that in a second. I just want to make sure I don't leave you without any tools. Okay. So let's write reverse string. Static string reverse string takes a string s as a parameter, and I want to reverse this string. Well, how many characters are in s? Now, don't look at your notes. How many characters are in s? Right here. If your whole world is right here, how many characters are in s? S dot length number of characters. That's how many characters are in s. Okay? I need to take whatever s is and I need to make it backwards. So in order to make a new string, I need to build a new string. So I'm going to say string answer starts off as the empty string. What am I going to do? I'm going to walk s from the end towards the beginning. Well, where's the last legal position in s? Hello, for instance, has 5 characters in it. Bucket 0, 1, 2, 3, and 4. So the last legal character in s is s.length minus 1. Okay? So I'm going to write a loop for int I is equal to s.length minus 1. That is, I will be the position of the last legal character in s. Keep going as long as I is greater than or equal to 0. Subtract 1 from I each time. So if the string s happened to be hello, I would go from bucket 4 to bucket 3 to bucket 2 to bucket 1 to bucket 0. What am I going to do each time? I'm going to say answer is equal to whatever answer currently is concatenated with s dot char at I. And then I'll finally return answer at the end. So to test this, I have my string s up here. I'll do a system.out.println s. And then I'll do a system.out.println driver dot reverse string of s. So I should see hello printed out, and then I should see hello in reverse printed out. Okay? And similarly, if I just change hello to be elephant, and then I run this again, it'll print out elephant, then elephant in reverse. All right, questions about any of that? All right, so let's talk about your homework assignment. Let's talk about the paper first, because this program is just going to be a nightmare. All right, so report number 3. You're going to write a 3 to 5 page paper discussing problem solving as related to technology. Specifically discuss when it is appropriate to use tools like Excel to solve a problem versus writing your own software to solve a problem. Using the right tool for the job is a large part of being a successful IT professional. Okay? So you're going to give your take. Or not necessarily your take, but also if you do some research and you want to give somebody else's take, that's fine too. But really, write about when it's appropriate to use a already built solution and bend it to your needs versus writing a custom solution. Make sense? At some point, there needs to be a litmus test. When you are a problem solver working in the IT industry and you're presented with a problem, you have to have some concept of when do I use something that already exists versus when do I write something on my own? Make sense? That's what this paper is about. Now, the programming assignment. I'm kind of cackling inside. The first 3 parts of this assignment are easy. The 4th part is hellish. All right, so you're going to write 4 separate methods. You can create more than these methods if you'd like. If you need helper methods for your methods to call other methods, you can do that. No big deal. But at least write these 4 methods. The first method is a method called print vowels. This method should take a string as a parameter and print all the vowels in that string, 1 character per line. So that's the first method. Second method, print consonants. This method should take a string as a parameter and print all the consonants contained in that string, 1 character per line. Third one, print digits. This method should take a string as a parameter and print all the numeric digits contained in that string. That is 0 through 9 are the digits. 1 character per line. Okay? Those 3 should not be very difficult. Relatively speaking. If number 4 is a 10, those 3 are a 0 or a 1 in difficulty. Number 4, it's called process expression. This method should take a string in the format of an integer followed by optionally a plus, a minus, a times, or divide and another integer 0 or more times. Your method should then process this expression and return the result as an integer. You must solve this problem using only tools that we've done in class so far. And here's some examples of inputs that your program should work for. For instance, if I passed it the string 125, that is an integer followed by 0, operator followed by integers, the answer should be 125. If I pass it the string 125 plus 7, your answer should be 132. That is whatever 125 is plus 7. If I give you 125 plus 7 minus 2, it should print out 130. 125 times 2 should print out 250. 10 divided by 3 should print out 3. Integer division. Not 3 point something, 3. Now, here's a hint and a warning. Actually, I think it's mostly a warning, but it's also a hint what not to do. Built into the language, and I will show you this next class, which makes this last statement, you must solve this problem using only tools you were taught thus far in 535. There is a tool built into the Java language that does allow you to convert a string into an integer. I'm going to show that to you next class. Therefore, for this assignment, you are going to have to write your own code for taking a string and turning it into an int. Make sense? So the string 125 needs to somehow become the integer 125 so that you can then do math with it. Because as long as it's still the string 125, if you use the plus sign, that's concatenation. Make sense? And again, I'm really trying to emphasize, you can only use things we've talked about so far in class. So not my first rodeo. I've seen lots of solutions to this problem where students go out and they Google and they come back with all sorts of, some of them working solutions. But if you're using things like string tokenizers and split and these are things you haven't been introduced to yet in my class. So you can only use this, you can only solve this problem using tools that I've taught you. That make sense? So everything you need to solve this problem, you've learned really in this class today. on top of like if statements and stuff like that from last class. But the main logic of what you need, you've learned today. All right, questions, comments, concerns, bribes? I mean, we can work with like a pooling of cash maybe. All right, I will see everybody next Wednesday. I'm sure you will have a very enjoyable week.